Hey everyone, same announcements as usual. Tutorials are Monday through Friday, 10 to 11 a.m. through the Zoom link in the announcements on Echo, and assignments are due Friday. I also included a link to an online simulator with vectors, so that way you could help with your assignments for the previous week and this week. And then this week, you're responsible for a vector review. I just want you to know that you should be able to, which is what this SWABOT stands for, is students will be able to add vectors algebraically and graphically, scale vectors, solve for the magnitude, norm, and length, and be familiar with vector notation. We also started working with vectors in real-world scenarios, but that's something that we should always be able to attach math to. And then also, you guys are going to start on a dot product practice, which this week's videos will help you with. Okay, so we are going to use both the component form of finding the dot product and the angle form to solve for the angle between these two vectors. So I put the first vectors that came to my mind, 1, 2, 3, 4, and we are going to find the angle between them. So here is the identity we are given in our text, and then what are the angles between these two vectors? First thing I would do is check to see if they were orthogonal. Because if they're orthogonal, then theta is equal to 90 degrees. And the way we do that is we check the component form to see if it's equal to 0. So, the vector 1, 2 dot product with the vector 3, 4 is equal to 1 times 3 plus 2 times 4, which is equal to 3 plus 8, which is equal to 11, which is not 0, so they're not orthogonal. So that means we're going to have to use this identity here to solve for theta. So we're going to use this formula above to have this 11 that we calculated before, and now we need to solve for the magnitude or the norm or the length, all synonyms, of u, and the same thing for v. So to solve for the norm of u, or the magnitude, we take the square root of 1 squared plus 2 squared, which is equal to the square root of 5. And for v, we take the square root of 3 squared plus 4 squared, and then that is equal to the square root of 9 plus 16, which is equal to the square root of 25, which is equal to 5. So therefore, we are given this equation, and then we can do some algebra to manipulate it. So we divide both sides by 5 root 5, as I did right here, is equal to cosine of theta. And so therefore, cosine inverse of 11 over 5 root 5 is equal to theta. So we're going to go to Desmos now. So you can change Desmos into degree form by coming over here and clicking on this tool option. And then down here it says radians, but since we are dealing with degrees as our angles, we are going to click degrees, and then I can say cosine inverse of 11 over 5 times the square root of 5, and then put a big parentheses, and that is my angle, 10.3. So our theta is 10.3, and if you don't believe me, we can check it using our trig that we've learned before. So if we have the vector u and v, and here it is in graphical form, we're going to take tan inverse of 2 over 1, because tangent of theta is opposite over adjacent, so tan inverse of opposite over adjacent gives us our angle, which is 63.4. If we do the same thing for our vector v, we have tan inverse of 4 over 3, opposite over adjacent, gives us 53.1. And then when we take the difference between them, we get 10.3. So I wanted to show you this additional resources as well. So if you go into the editor, you guys should be able to see something that looks like this as your assignment. And so what you do is you click on this link, and then click play, and then explore 2D. And what you can do is you can take vectors. They call it A and B here. I've been calling them U and V. And you can click on vector A and see its magnitude, which is also called the norm or length, along with its angle, its x component, which is 7, and its y component, which is 16, which is right up here. And then something I think is really cool is over here you can put the angle, and you can see how it changes as you change the direction of your vector. And then also you can sum your two vectors and see the resultant vector of them both. And so it'll change as you alternate it. And so I just thought this was a really cool resource you guys could play around with to get used to the vocab and to summing the values and seeing it graphically.